share as many code as possible, but separate their unique function. That is the purpose or goal of the thread. Okay, so thread motivation. Check your attendance after class. Only him. You are the next. So I told one person in China, so I visited Wuhan, not Wuhan University. I heard that Wuhan University, we have several Chinese students. Wuhan University is one of the top universities in China. The Wuhan Science and Technology, Wuhan University of Science and Technology University. I told to the microcontroller, a microprocessor, not controller, microprocessor. So at the end of the semester, almost at the end of the semester, some of the students, I think almost 1/3 of the students missed the class, but I didn't check the attendance at the time, but that was the first time. But right after I started to check the attendance, all the other students come in. They actually prepared the exam for another class in other room. So at that time I realized, I asked them, how do you know? They said that they have they are using the WeChat. The WeChat is a messenger. So they, every time, they're texting and messaging, everything. Okay.
In Chinese or English?
WeChat?
Did you teach in Chinese or English?
I cannot speak Chinese. In English. That was the reason why I visited in China. But that was the problem. Everybody expected for me to speak Chinese. So whenever I go to the shopping mall or wherever, they expect for me as a Chinese, but I couldn't speak any Chinese. So if I speak in English, so they surprised. Why you cannot speak Chinese? It looks like the 100% Chinese. Okay, so motivation is actually the main reason of the learning the operating system is we have the limited resource. We try to maximize the utilization. So this is one of the ways. As I keep saying, that if we have the unlimited resource, I think the operating system class will be 2 or 3 weeks. That might be because we can assign as any resource to the request process. Unfortunately, we do not have such an unlimited resource. It's not possible. So that is one of the ways. Why don't we share as many component as possible? Then separate the unique part. That is the idea. Then we can save the computer resources. So like this one. So for example, this is a PCB of one process. What is a PCB? Next. Yes, so you can check your attendance. Then next. So this is a process control block that can represent each process, which means so with the PCB, actually we can understand most of the information about the processor, pointer, process state, and the process number, and the PC. What is the PC? Control. Counter, which means address of instruction. Okay, it's the address of the instruction, and then next, because in the PCB, so you cannot use CPU time forever. Sometimes it's the wait state, then or you need to go back to ready state, and you should memorize. The operating system should know when is the next instruction. That is saved in the PC, the program control. Okay, and memory or all other information at that time. So if in case of the MS Word, so for example 3,000 to the 30,000 address. This is for this is for spelling checker. This is for display, and 4,000 display and 3,000 is for the typing. So we can separate this. Okay? Then we consider each thread as a process. Okay? It can be separately scheduled by the operating system. Then we don't have to keep this information for each thread, only the different parts. So we will see which part will be shared, which part is not. For example, yes?
How do we decide to identify or...
In your program, you need to decide actually. This is just the high level, the structure.
Is it like function call? Or
Yes, like the function. That's a good question. How can we make the thread, right? So in your program, you need to make the function for the thread, okay? That's also very important nowadays. For what? Multi-core programming, okay? So for example, so your laptop is a quad-core. Mine is still single core. so sometimes the student or the user complain, I have the quad core and the 8 core, but I cannot get the speed of the increasing linearly. Why? Because your program is only using only one core, single core. So that is the reason. So to get all the benefit of the multi-core, your programming, your application should be functionalized, modular. That is a thread. Okay, thread is one of the way to get the benefit of the multi-core, multi-programming by function, by logically. Okay, so that is a good question. But this is just an example. However, some of the operating system provide even single core. Try to. Some of the application can be divided into thread. Sometimes not always. Sometimes.
So,
Yes.
what I understood from your explanation that in our programming, we actually have to make our function as a thread.
Yes.
If we don't do that, then the whole program is only one thread.
Yes. In general. But some of the operating system try to consider run as a multi-thread for single function program. Not always, but some of the application can be, depending on the operating system. That is the issue of the parallel program. Okay, I think the Professor Mahmoud he's offering the parallel programming. If you take this course, that course, you will learn how to separate logically. Okay, so what can be the however, we cannot share all the information. For some part should be independent. That is the first step pointer. What is the step? It's in the memory structure. Then what kind of information in the step? It's a binary. It's a temporary data will be stored, which means for each thread they need the temporary space, so they cannot share. For example, I have the backup drive, so can I share my backup drive with other? Then maybe. Other example, your private. This kind of private information, we will throw away such the temporary data, so stack information cannot be shared. Okay, so thread and register, because it's one thread of the instruction. So register information can be different by the thread. So stack, register, and each thread can be considered as the process, so it can be scheduled. So scheduling information. And other pending and block signal, because it can be act as the process, and thread specific data, except this data, the other information can be shared, mainly data, okay, and text information in the process. Okay, global variable, you don't have to keep the global variable for each, you can share. And also, the programming code can be shared, because it's anyway one program. So except this, we can share the process that is called the thread. So in terms of PCB, so program counter, register information, and the scheduling information. Okay, thread scheduling, lightweight, heavyweight, we will see the later the scheduling information about the thread. So other than that, we can share this one, which means when we create the process, it will be one PCB is created, and then whenever you make the thread runnable, then it will be created additional part of the PCB, okay, for each thread, like this one. So as he mentioned, it will be, when you code it, it should be kind of function, okay? So I think that this one shows the more clear example. So it's an example of the POSIX. POSIX. What is the POSIX? Last chance. The portable operating system for Unix. It's a kind of standard. Okay? So that is the reason I'm showing a lot of POSIX something. This is an example of Unix. Okay? Okay? Then it will be used for eventually macOS also, because the kernel level of the macOS is the same as the Linux operating system. Anyway, so this one you can see kind of routine. This is a function. Function is one thread, another thread. It's one process. The data structure is in the memory, but it will create the two threads. It has its own stack area because the stack cannot be shared. Okay, and other register information and counter, program counter. Okay, that is different from the single thread, the regular processor. It has only one stack and one information. So which means when it should be considered if we want to use the thread in your program language. What about the Java? Oh, you want to answer? What about the Java? Java, actually, how can you execute the Java program? Java and class name. What happened?
It's compiled.
Compile?
No, it's execute.
Execute what?
Class file. Execute.
Class file?
Execute.
No, before that, virtual machine will be executed. Actually, Java virtual machine is my child process. When I learn the Java class file, okay, then the runtime module, Java virtual machine will be executed. That is process. Then class is a children process. No, it's a thread of that Java process. Can you see a lot of Java? No. Only one Java that represents the virtual machine. Then inside the virtual machine, so any process can be considered as the thread in Java. Okay? Which means you can share the many of the information regarding to the Java. You don't have to create again, load it into the memory, only Java. Then whenever you call another class, it will be executed as a thread. Okay? So that is the thread, concept of thread. So this one clearly shows the difference between the single thread and multi-thread. So you can see the main part is the stack and register information that is not shared otherwise. The code, data, and file, open the file, will be shared for each thread. So that doesn't mean we can increase the CPU time. Instead, we can schedule separately such a thread. In terms of scheduling, so it will be considered as in the process. It looks like a multitasking. Each thread will be considered as a multi-task job. Okay. In case we have the multi-core and multiple process, we can get the benefit of the parallelism. Okay, so we can assign the operating system can assign this thread to the CPU1, this thread for the CPU2. It will be physically executed at the same time and will be faster. benefit. First one is, even though one of the thread is terminated, forcibly terminated or something problem, so it's not executed, but we have another thread. Also, the first example that I used for thread was finding prime number. Have you ever did that? What is a prime number?
Can be divided by itself.
Yeah, you know the prime number? So how many prime number we have? If I know, so I will be Nobel Prize or the field medal. So nobody knows how many, but it's not. So the only way is we need to find one by one from there are actually the big project, supercomputer project, to find the biggest, not biggest anyway, big, and the next prime number. So how can we speed up? We can divide the job. So my computer works for the 0 to 10,000, and yours is 10,001 to the 20,000, and something like that divide. At that time, you can create the thread. At that time, you don't have to create a different thread. You can create one thread, but execute many times. Then your operating system, if your operating system can handle such a multi-core programming, then assign each thread for different the core or different process, then you can get the full benefit of the parallelism. So also, one of them is the terminated. Don't worry, you can restart the thread are running. Of course, the terminating one thread does not affect the entire your process. Even though you cannot survive here, so your parents still alive. So then, definitely, this is one of the main reasons, the resource sharing. We can share a lot of resources in the memory. Because of that, this slide, did I do that? No. So somebody has to evaluate how fast the creating thread comparing to the creating the process. It's 30 times faster. It's a huge, okay? So in case your operating system needs a lot of creating and terminating process, instead of the creating new process, you can create the thread. Okay? So I think that you can test it. We can test it. Same thing. So it's that we can make the two program, like fork and exec, loop the many times and check the time. Also, similarly, we can create the thread. Okay? So also, because of this, we can get the utilization of what is the MP? Micro. MP stands for massive processor. Okay, parallel programming, massive processor. Okay, so when we have the many CPU, like the SMP, okay, symmetric massive processor, like your CPU computer. So it's a massive, not just one, it's a many. So at that time you can get the full benefit of such a parallel processing. Nowadays, we have the Hadoop system. The one time I will introduce such a distributed system based on the Hadoop. It's related to a lot to the operating system later. Okay, so we will continue the rest part of the thread on Thursday. Okay. So why don't you check your attendance if you are late?